Volume of cylinders, cones, and spheres. Let's begin with how the cylinder, cone, and sphere are related to one another. So the relationship here, we're starting with the cylinder. The cylinder, we know, has a volume of the base area times the height. And here you can see the base area of the cone is the same and the height is exactly the same. The sphere is also the same height and it has the same diameter as not only the cone but the cylinder. So how many cones does it take to fill that cylinder? And this is how we're going to figure out our formula for a cone. So I'm going to fill it once and maybe you have a guess. Here's the first. And you can see it fills not quite half. Here's the second. And you can see that it fills almost to the top. So we got a little bit more, and it appears that it takes 3 cones to fill that cylinder, meaning 1/3 of the cylinder is equal to the volume of the cone. Now let's see how the sphere's volume is related to the cylinder and the cone. They both have the same diameter on the interior of these shapes. So I'm going to fill the sphere to the top as best as I can, and then I'm going to empty it into the cylinder, and let's see how much it fills. And you can see it appears that it's 2/3 the volume of that cylinder. So let's do a little bit more just to prove this so that we can see that it actually is 2 of those cones that will fill that sphere. So I'm going to pour from the cylinder into the cone. And here's our first. So it's 1 cone. And it takes 2 cones. There you go. So 2/3 of the cylinder, or 2 cones, equals the volume of a sphere with the same diameter of that sphere. So we can use the volume of a cylinder, which is the base area times the height, to find the volume of our sphere. So you can use 2/3 the volume of the cylinder to find the volume of our sphere. Because the height is really our diameter of the sphere, we're going to rewrite this as 2/3 pi r squared times the diameter, and then change that diameter into twice the radius. So we get 2/3 pi r squared times 2r. And then we want to simplify even further, where we have 2 times 2/3 pi r squared times the r to get our formula of 4/3 pi r cubed. Looking at our formulas side by side, our cone is 1/3 base area times the height, cylinder base area times the height, and sphere is 4/3 pi r cubed. So looking at volume of a cylinder, we can see here in our image that that base area is a circle, and if we multiply it times 1, it's the same, except we're looking at the volume cubed. And then we're going to multiply that by how tall it is, so how many layers is our cylinder. So looking at the first example here, we have base area times the height. So the base on this cylinder here is pi r squared. It's a circle. So we're going to use 3.14 times our radius 3 squared times the height of 1.8. And that will give us the volume. So go ahead and simplify. you always want to start with that exponent here. Remember PEMDAS. 3 times 3 is 9. And you don't have to go through every single one of these steps. You can just simply go across and multiply, but don't forget you need to multiply using this exponent first. And remember, it's not 2, it's squared. And then when you multiply across, 3.14 times 9 times 1.8, that gives us a volume of 50.9 inches cubed. Remember, it's a 3D space we're looking at filling, so we're going to use to the 3rd power. Take a look at the next problem. So on your quizzes you have word problems, and we're looking at what is the volume of a barrel that has a diameter of 1.5 feet and a height of 4 feet. So the first thing we have to use here is not the diameter. Remember, we're using our radius. So we have to half this because we need the radius. So if the diameter is equal to 1.5, our radius is equal to 3/4, which is equal to 0.75. And we're going to use the decimal equivalent here. So let's set up the problem. The volume is equal to the base area, which is going to be pi times the radius squared times the height. It gives us a 4. Next, let's simplify the exponent. So 3/4 times 3/4 is a nice long number. Now, as much as you may want to simplify to the nearest 10th or 100th, don't do that until the very end. Let the calculator do all the work. So you're going to leave it as 5,625 10,000ths. And then multiply straight across. Or you can just keep that number in your calculator, times pi times 4. The order doesn't matter. And you're going to end up with approximately, and back in the directions it says to round to the nearest 10th, 7 1/10 feet cubed. So the next problem we're working on is the volume of a cone, and earlier in the video you saw that one cone filled up 1/3 of the cylinder. Do you remember? It was 1/3. So here we can set this up with this large fraction. And again, we're taking that base area. So the volume is equal to 1/3 the base area times the height. So let's look at the base area here. So our radius is 2. So the volume is equal to, we don't need the 1 there, the base is pi radius squared times the height, divide by 3. Second step, simplify the exponent. So we know that this is going to be 2 times 2 is 4, and 4 times 7 is 28. So I'm going to stop right there for a second. Volume is equal to pi times 28, divide that by 3. Now, when I talk about estimating your answer, when I look at this, pi divided by 3 is close to 1, but it's a little bit more. So when I look at this 28, once I've simplified part of my problem, I expect my answer to be close to 28, but a little bit higher. So go ahead and complete this problem. Pause the video if you need to, and let's see if you come up with the same answer I do. Again, remember, it's asking you to round to the nearest 10th. So you should have that it's approximately 29 3/10 feet cubed. How'd you do? So the next problem asks us to find the volume of this cone that has a diameter of 10. We're going to use 3.14 for pi. So as I start this, I know that my diameter is equal to 10, therefore my radius is equal to 5. And then I'm going to go ahead and set this up. And if it helps you to write out the equation using the base area pi r squared times the height, remember that's a cylinder, divide by 3 is the cone, or you could do 1/3, it's up to you. So here my volume is pi times my radius of 5 squared times the height of 9. And divide that all by 3. So let's continue to simplify. Remember, we want to do the exponent first. 5 times 5 is 25. 25 times 9 is 225. So let's go ahead and look at this estimate. So it's pi times 225 divide by 3. Again, this simplifies to about 1, so my answer should be just over 225. It's approximately, you tried it out, 235.5 millimeters cubed. Volume of a sphere. So remember, the volume of a sphere is equal to 4/3 pi r cubed. And in the example I showed you, that sphere with the same diameter and height as the cylinder only took up 2/3 of the cylinder, or it took the same as the two cones with the same diameter and height. So here on the first example, it asks you to find the volume of each sphere and round your answer to the nearest tenth. And we're going to use 3.14. You could use 22/7 as your estimation for pi, but we're going to go just with that 3.14. So if it helps, just jot down your formula. 4/3 pi r cubed. And we're going to set this up with that long fraction bar. And so let's fill this in. So we know it's 4/3 pi times the radius of 22 cubed. So the first thing we need to do is simplify this. Remember, this is 22 times 22 times 22, not 22 times 3. And that's going to give us 10,648. So that's the simplified. So our volume becomes 4 times pi times that 10,648. Divide that by 3. And when I multiply this 4 and the 10,648 together, I'm going to get a number that's really close to my answer. So we get that the volume is equal to, and then these two are equal to 42,592, meaning because these two again approximate to 1, my answer should be just a little bit over this because of the 0.14. So when I take and I multiply 42,592 times 3.14 and then divide that by 3, you should get that your volume is approximately 44,579 and 6/10 inches cubed. Number 2. Amber is purchasing a ring that contains a 7.5 millimeter diameter round pearl. Find the volume of the pearl to the nearest hundredth. So we're going 2 places out. Now you're going to get a really long decimal on this one, so I don't want you to round it until the very end. So this is 4/3 pi times the radius cubed. So the volume is equal to 4/3 pi. Now our radius, now when we're doing the radius here, it gives us the diameter. So it says the diameter is 7.5. If you're not sure what half of that is for the radius, then go ahead and take and divide that 7.5 by 2. And notice you already are getting a number to the nearest hundredth here. Once it starts getting longer, because when we multiply this times itself, it's going to get even longer. I don't want you to round until the very end. Let the calculator do all the work. So the next step here, we need the radius times the radius times the radius. So here our volume is equal to, and if you don't have the button cubed, or it doesn't matter, you're just going to need to just take 3.75 times 3.75 times 3.75, and you end up with 4 times this really long decimal, 52.734375. And all of that is divided by 3. So the next thing, let's just multiply this times 4. And you don't have to clear anything out. You can just push times 4. So I know my answer is going to be close to 210.9, but it's going to be a little bit higher. So let's go ahead and multiply by pi, then divide by 3. So we get 220, so the volume is about 220 point, so I need to the nearest hundredth, 10th hundredth, that's a 1, 4 less, let it rest. So we're going to go with 220.78, and this is in millimeters cubed. So again, don't round this off as you're working through the problem. Let the calculator continue to solve it for you. You only round it at the very end. Finding the height of a solid. Use the formulas to find the height of the solids. Use 3.14 for pi. So the first problem here asks, given a cylinder with a volume of 392.5 meters cubed, and a base with a radius of 5 meters, what is the height of the cylinder? So here we need to first, let's start out with what is our formula. So formula is the base area, which is pi r squared, and then we're looking for the height of the cylinder. So we know the volume is 392.5. We're going to use 3.14 for pi. The radius it gives us is 5. We need to square that, but we don't know the height. So again, using PEMDAS, no technical parentheses, but we do have this exponent inside here. So 392.5 is equal to pi. 5 times 5 is 25. Times the height. So the next step, we could divide both of these into 392.5 individually, but let's start here with, again, simplifying on the right. So we have pi times the 25 is 78.5. So we have 392.5 is equal to 78.5 times the height. And we have one more step. So the opposite of multiplying here, our inverse operation, is dividing. So when we divide on the right side, it cancels. So that our height, if we take 392 and a half, divide that by 78.5, we're going to get 5. So whenever we're looking at what is the height, it's going to be 5 meters. Not squared, not cubed. This is just the distance. And if it helps, draw yourself a little picture. So the height is equal to 5 meters. And we also know that the radius itself was 5 meters. Last problem here. So it asks us to find the height of the cone and use 3.14 for pi, round to the nearest tenth. So again, let's start with what is the formula. The formula is 1/3 the base area, pi r squared, times the height. Sorry. So the next step here is just going to be, let's fill in the blanks with what we know. So we know the volume, which is 1,205 and 76 hundredths pi. The radius is 12. I'm going to square that, times the height, divide by 3. So next step. There's a couple ways that we can go about this, but the first thing we really need to do is go ahead and simplify this. So when I'm looking at 12 squared, I know I have 144. And then you can either multiply by 3 on the other side or simplify on this side and then divide. We're going to just simplify on the right and then divide. So pi times 144 gives us 452 and 16 hundredths. Divide that by 3, and we end up with 1,205 and 76 hundredths is equal to 150.72 times the height. Next step, let's divide that on both sides. So it cancels on the right, leaves us with our height. So 1,205. Are you doing this with me? And our height is equal to 8. So again, when we're looking at this image, we know that 12 is our radius, and this height, I have a lot of students that will tell me that the height is 8 inches squared or 8 inches cubed, but it's just the distance from that center of the base to the top of the cone. So just remember, if you are still having trouble after the video, I will go back through these problems on my Zoom. Join the Zoom at least 4 times this week, along with the Kahoot later on this week I will do. And you can use 22/7 as far as pi is concerned, but I believe the Florida Virtual actually asked for you to use that 3.14, so I would suggest using that, and don't round again until the very end of the problem. Let the calculator do all of that math for you. And today is May the 4th, so May the 4th be with you, and come to the Mass side because we have pie, remember. And I hope you have a good week.